Okay, hi guys. So in this lecture, we will be dealing with the reaction of compounds with PCl5. Okay, so let me write down the heading. Reaction with PCl5. Okay, so let me illustrate this with an example. So suppose we have a primary alcohol or a secondary alcohol, any type of alcohol. So what will happen on reaction with PCl5 is we will get something like we'll get alkyl halide plus POCl3 plus HCl. Okay, so the mechanism of this reaction goes as follows. First, in the first step, what happens is ROH plus PCl5 actually makes the bond weakens between O, and O gets a partial positive charge because it actually forms a bond between P, and this bond actually breaks just like in SN2. The Cl one Cl minus is released from P atom. Maybe you can, okay, I'll show you just like this. These are 2 Cl and 1 P is like this. So this Cl is released from P atom, and in this state, the intermediate state, the bond formation and breaking happens between happens between O and R, and bond formation happens between P and Cl. Okay, so this is a SN2 step. Okay, so after this, what happens is after this, the RCl minus actually attacks on R, so we will have RCl plus this is another intermediate wherein O actually donates its electron and gets a positive charge on it, and Cl also breaks off. So what happens next is Cl after breaking takes this electron, this H plus atom. So the final step, so this was the first step, this was the first intermediate, this is the second intermediate, and this, after the second step, what happens is we get something like RCl plus this HCl and P double bond O Cl, so POCl3. Okay, so these are the products. Okay, so this is an example of electrophilic substitution reaction. Okay, oh my bad, nucleophilic substitution reaction. Nucleophilic substitution reaction, as you can see that Cl minus actually attacks the R plus carbocation from the first step. Okay, we'll see some of the more examples of the same. The next example is suppose we have ROR and we react with PCl5. So what would the product form? Product form would be 2RCl plus obviously POCl3. Yes, that's all. So what happens in this reaction is, first this O actually attacks on PCl5 to remove this chlorine atom and to form a bond between remove this bond between R and O and form a bond between This will be the intermediate. Okay, in the next step, this is the SN2 step. In the next step, R will form bond between Cl, as Cl minus attack on this removing to be removed R from this intermediate. So now we have something like this. So now in the next step, what happens is Cl will oxygen will donate its lone pair with to P to form a double bond between it. Meanwhile, it will the P will actually, the Cl minus will actually remove withdraw its electrons from P, and similarly R will, so the O will actually not it will not donate its lone pair to, it will actually donate its lone pair, you can say, to form a positive bond, and then this bond will be actually withdrawn by O to remove its positive charge on itself. Okay, so after this we would have RCl plus, then this removing Cl will actually attack on R to procure R, because this Cl will be removing as a negative charge, and the negative charge on Cl will actually attack on R to remove itself from the, to remove R from O and create a double bond, create a bond between R and Cl. Okay, so next we will have POCl3. Okay, so I hope by now the mechanism is pretty clear to you. So what is the products when we react this with PCl5? So the products would be these. And how does it happen? Suppose we have O, R, this O will actually attack on PCl5, and what will happen is this Cl will withdraw its electron, and the O will form a partial bond between itself and the P atom. Okay, and the Cl minus will actually attack on this carbon atom in the next step to remove this bond is actually in the on the verge of breaking itself, the double bond. So what will be the intermediate? This will be the intermediate in which we have O. O is forming a bond between PCl4, and this is a R again. Okay, so this is the intermediate we get after the first step. So now what happens next is, again the O will actually donate its electron, the lone pairs, to form a double bond between P and itself, and this Cl will be actually withdrawing its electron, and this Cl will be actually attacking back on the bond which is breaking between C and O, or the positive charge on carbon. So hence we will have something like Cl here and R here, plus P double bond O, Cl3 would be there. Okay, so with this we get our this product. Okay, so let's take a look on the fourth example. In here we have this reacts with PCl5 to form products which will be forming, it will be forming this type of product, because you know that breaking a CO bond is more harder than breaking a CO bond. C double bond O bond is more harder than breaking a C single bond O bond. Why? Because of bond energy order. Okay, CO bond energy is more than C single bond O bond energy. Hence, this O will attack on PCl5 to form HCl and ROCl3, RCOCl. So this is this product is formed. Okay, let's talk about this case. But when in the above example, when there is no other option left, this CO bond will be getting itself broken up. Okay, now let's discuss about this example. PCl5, what will happen is, we would have, again we have actually discussed the mechanism in the previous example, so will not repeat itself. So basically now what you have to do is replace all the single bond O and double bond O with Cl wherever required, and wherever this is reacting with PCl5. Okay, what about this? Let's bring it as CS3. PCl5. So what would be the product? Simple, Cl, Cl and CH3. Seventh one would be okay. So this is the summarizer which I am just writing. So these are not actually examples, these are actually summarizers. As to how you should approach all these problems. First is this, second is this. Okay, let me make it with a different color. So this is actually what I'm trying to show here is, this was a single bond between R and O, and let me remove this also. This was a single bond between R and O. On what will happen is, on reaction summary, on reaction with PCl5, so what will happen is, this bond and this bond will be broken up and the position will be taken by the halogen. Similarly, in this case also, the double bond between C and O will be broken up and the positions will be taken up by oxygen atom, Cl atom. Okay, let's take a third example. In third example, if we have RCO double bond O, OH, then bond cleavage, this bond will be cleaved and this bond will be cleaved, and here Cl and here Cl will be formed. Okay, and the resultants would be 2RCl plus POCl3. Here would be RCl2 R plus POCl3, and here it would be RCO Cl plus HCl, obviously plus POCl3. Okay, let us look into some more examples. So here we have on reaction with PCl5, the product would be this, obviously plus POCl3. Okay, with this we would have RC double single bond C, single bond C, H, ClClH plus POCl3. Okay, we'll have something like this. And in this case, what will happen is, on reaction with PCl5, this bond would be cleaved and this bond would be cleaved. Okay, so we'll have something like 2 RCOCl plus obviously POCl3. Okay, we would have, then next example is reaction with PCl5, we would have plus HCl plus POCl3. Okay, so in this case, what would happen? As in the first step, SN2 reaction takes place, and in the next step we will have the R plus formation. So we can say that when actually the Cl minus attacks R plus, it can actually attack from both the sides. So we can have either this one, we can either have this one, or we can have this one. Okay, So this should be the range of products formed. Because in the first step is actually a SN2 reaction in which a bond breaking between R and O happens, and Cl minus is released, and a bond formation between O and P atom also takes place. So in the next step, what happens is R is completely removed from the O bond by the attack of Cl. Okay, so in that step, actually Cl can actually attack from above the plane or from below the plane. Okay, so from this, with this we can conclude that actually by the attack of Cl, it can make racemic, it can racemize the products. Hence these are the products or range of products obtained. Okay, let's say we have something like this. We reacted with PCl5, what would happen? You would have something like this. Plus PuCl3. Next we have so here we'll have this would be in the first step, but you know NH2 is here, so what would happen is it will donate its lone pair, get a positive charge on itself, and Cl would be actually removed from here. So you will only have one Cl with a double bond with NH2, and the release Cl minus actually will attract this H to form something like plus HCl, and again this lone pair on nitrogen atom will be used to form a bond between R and C. So thereby this Cl will be removed from the carbon bond, and the removed Cl will actually attract another H plus towards it, and hence we have a formation of nitrile plus HCl is reduced. Okay, so keep this reaction in mind. This is used for the preparation of nitrile from acid amide or just amide. Okay, let's look at the last example, and here we have something like this. We have PCl5 here. So you remember that the first step was the SN2 step. So in the SN2 step, what will happen is the released so let us draw the mechanism first. So let's see the mechanism only. We would have something like this in the first step, where we will have O plus here, H attached to it, and we have, let's say it is a PCl3 here for now. So one Cl will be removed from here, plus Cl minus will be removed from here. Okay, so I'm just showing the Cl here. So what will happen is this Cl will actually attack from backhand side, because in the front reaction attacking from the front, actually it's facing some steric hindrances. So this would be the major product formed after this reaction. So as it is attaching from behind, it will have dash Cl and obviously OH PCl2. Okay, so with this we come to an end of this lecture. From next lecture we'll be seeing SN-NGP or neighboring group participation. Okay, so till then, good luck and goodbye.